All right, for Newton's second law, what this is taking a look at is we have the amount of inertia a body has is measured by its mass. So massive things have a lot of inertia, meaning there's a large force required to change the motion, right? Because inertia is an object's resistance to motion, right? More inertia means more force to get it to change that motion. So here, if you have large inertia, you need a large force to get this boulder to start moving, okay? Over here, you have small inertia. It requires a small force. Now, if there's a change in the velocity, then that means the object's acceleration, all right, will exist, all right? If there's no change, so like if we keep applying a force and this doesn't move, right, then we're in equilibrium. And that means that there is no acceleration. So second law of motion is that the net force is equal to mass times acceleration. Well, remember, this mass, that's a property of inertia, right? So whenever we're talking about a force needed to move an object, we have to take the mass into consideration because we need, for a greater mass, we need more force to even cause it to accelerate. Okay, so the more force on an object, the more it's going to accelerate. But the more massive it is, the more it resists acceleration. So we have these two ideas. We have mass is force divided by acceleration. Acceleration is force divided by mass. And what we want to do is I want to draw a couple pictures just to give you guys an idea. So let's say we have the same mass. So I'm going to look at an object with the same mass here. Okay, and we're going to call this same mass M. So M and M. And I'm going to make one difference between the two. I am going to make this force really big, and I'm going to make this force really small. Okay? What can you tell me about how this mass accelerates versus this mass if they're the same? The first one is going to have a greater acceleration. So here, the acceleration, so we'll say force 1, force 2. The acceleration here has to be greater than the acceleration for object 2. Okay? So since this is a greater force, it's going to have greater acceleration. What do you guys remember about the direction of force and acceleration? So that if you have a net force here, right, which direction is acceleration? If the net force is to the right, it also has to be to the right. So let's add a little note here so we don't forget. The net force and acceleration are always in the same direction. All right, so the net force and acceleration are always going to be in the same direction. So here, if I were to draw acceleration vectors, they would both be to the right. And acceleration 1 would be a larger vector than acceleration 2. Okay, so that's one scenario, but let's take a look at another scenario. Let's say the masses are not the same, but now let's say the forces are the same. So we are going to say same force. Okay, so this time we're going to have mass 1 and mass 2. In this case, mass 1 is bigger than mass 2. But we're going to apply the same force. Okay, and the forces are the same size. What can you say about this? Which acceleration is bigger, the acceleration for 1 or the acceleration for 2? The acceleration for 2. So this time, acceleration 1 is less than acceleration 2, right? Because if I'm applying the same force to an object with more inertia, it is not going to accelerate as much as that force will to an object with smaller inertia.